Here we are again, polynomial practice test. We are on number 26. We are finding the oblique asymptotes. Okay, let's jump in and see what this looks like. Okay, so to find the oblique asymptote, first of all, we have to look at the numerator and the denominator and determine if it has an oblique. So if you go back and let's look at the horizontal rule, there was a rule for the horizontal. Oh my goodness, where did everything go? There's a rule for the horizontal that says if it's big on top, there's no horizontal. Okay, and so when we go to the obliques, that's what we're looking for, big on top. So first of all, it has to be big on top, and it has to be big on top by exactly 1 degree. So this one has no vertical, no horizontal, because it's big on top, but it does have a vertical. Wrong, does have an oblique. Okay, I'll write it correctly. I can't say it right. So, big on top by 1 degree, it has an oblique. That's the rule. How do we find it? We do synthetic division or long division, depending on the situation. We are going to do synthetic, because an oblique asymptote is a slanted line. A slanted line is going to look like y equals mx plus b. So let's do our synthetic division. 5, -1, 0. You forgot about that. And we're going to divide by +1. Forgot about that too, didn't you? So 1 times 5 is 5, and that gives us a 4. And that gives me a 4, and that gives me a 4. So now our answer, again, y equals mx plus b. We don't need the remainder. That is y equals mx plus b. That's the answer. That is the oblique asymptote. Now, that is a line with a slope of 5, and so when we're doing our graph, we literally have to find this slanted line. We have to look for this one. So if x is 0, and I plug that in, I get 4. So I'm looking for 0, 4. And this is a slope of 5. If I plug in a 1, I'm going to get 9. So I have a slanted asymptote like this. Okay, and so that's what I'm looking for. This particular one also has a vertical asymptote at 1. So I have a vertical asymptote at 1. How'd you get that? Right here, vertical asymptote at 1. And so I'm looking at this particular function possibly looking something like this. Could be wrong. Probably need to look at my answers. I think that's right. Let me look and see what the correct answer here is. Yep, that's it right there. Looks like this. Okay, let's do another one. All right, 27 asks for the vertical, the horizontal, or the oblique. So we've got to do all 3, and we could say none of the above. Okay, so now let's just keep thinking. Vertical, we set the denominator equal to 0. The horizontal, we compare degrees. And oblique, we do synthetic division. Okay, so now let's go through and do these. So the vertical, I'm going to do 6x plus 5 equals 0. Subtract 5 on both sides. Divide both sides by 6. I get x equal -5 over 6 is a vertical asymptote. There's no holes here. All right, horizontal. Let's look at the degrees. This one's tricky. The degree of the top is 1. The degree of the bottom is 1. Check it out. They put it in the wrong order. And then we look at the numbers. So the horizontal is going to be y equal -6 over 6, which is y equal -1. That's the horizontal. Now, you can't have both horizontal and an oblique. So you've got an answer for that one. So no oblique. You can't have both. It's either or. It's either or for the horizontal oblique. Okay, 28. Same question. All right, the vertical. Set the denominator equal to 0 and solve. Here we go. So we have x plus 4 equals 0. X equal negative 4 is the vertical asymptote. No holes. Horizontal. Compare the degrees. 2 and 1. This is big on top. No horizontal. Okay, so now that means we might have an oblique. Oblique, yes. It's big on top by 1. So we're going to do our synthetic division. So we're going to do synthetic division. We're going to use 1, 0, negative 3, and we're going to divide by negative 4. That's what we're going to divide by. Okay, make sure you understand where the 0 came from and where the negative 4 came from. There's no number, there's no x squared, so there's a 0, and then we always change the sign. So now let's do it. I don't need this number because my oblique is y equals mx plus b. So y equals 1x minus 4. That's my oblique. Okay, now this one is a picture and it's asking for the same thing. So here we go, we're going to look at the picture. We've got to look very carefully. The vertical asymptote, there's one. It's very light and gray. It's right there. It's right here at 4. So there's that one vertical asymptote at x equal 4. Horizontal, here it is right here. It's very light, and it's coming in at y equal 5. Now the domain, because of all the arrows, the domain is everything except the 4. So our domain is negative infinity to 4. Skip the 4 and go to positive infinity. That's my domain. Because the vertical asymptote is a break in your domain. That's why. The vertical asymptote represents a break. All right, last problem. Here we go. Last one. The vertical. Now this one we have 2 vertical asymptotes. 2 vertical asymptotes. One of them is at 3 and the other one is at negative 3. So the one on the left is x equal negative 3. The one on the right is x equal 3. And yes, you have to type the x equal part. We have a horizontal. Here's our horizontal one right here. And that's at y equal negative 3. Okay, now my domain again goes back to my vertical asymptotes. I omit, leave out the negative 3 and 3. So it's negative infinity all the way up to negative 3. Skip the negative 3, go to positive 3, skip the positive 3, and go to infinity. There's my domain. Because my domain has these gaps. Yeah, that's part of it. That's the domain, and that's the domain. So check out your domain in red. Okay, skipping the negative 3 and skipping the positive 3. We have gaps there. So that's the domain there. All right, that's it. Good luck. It's just math, y'all. Get this polynomial test knocked out. Y'all have a great day.